Well, I think that says live. Hey, so welcome to the last homework help sessions, 5 o'clock, let's learn something, etc., etc. This is number 11, you know the drill. I know we didn't do all 11 because the first maybe 2 or 3 or maybe 4 we didn't do, but we've at least done the last 6. You're all familiar faces. You guys want to cut to the chase? Yeah, let's do some chase cutting. What I've done today, and this seems to be the format that works the best, is I have the assignment, which looks just like it does on Sakai, except it's made out of paper, and it also has the answer key parts here. So while yes, you can see the answer key, and that sort of spoils some of the interactive part of it, and I don't like that. It does prevent some of the other challenges which entail when the answers aren't there, there's a challenge in the key, something. But more importantly, we get through the true-false questions so you can get that knowledge base in your brain. And then when we get to the homework problems, the math problems part of the problems part, which is this stuff, we'll be able to quite simply execute these problems because for all 10 parts, part 2 through part 11, it's the same basic questions asked over and over and over again. What's the value of the correlation? What's the y-intercept? What's the slope? Actually, what's the slope? Then what's the y-intercept? And give me some y-hat given some x. Wash, rinse, repeat. Except the data, because it's a homework assignment, you can actually work with some of this stuff in Excel as opposed to me just providing you, like if you've seen the practice quiz that you'll be taking on, or the real quiz you're taking on Wednesday, the practice quiz, which is available, you'll see that the practice quiz section, which is on regression, I just give you a mean and a standard deviation for an independent and a dependent variable, along with the correlation. I give you those 5 values, and then it's up to you to decide which one's the independent, which one's the dependent, calculate B, calculate A, and then make a prediction. But in this case, I can actually show you, given some data, how do you calculate those things. I know that we've done it in class a couple of times, but should be getting something that you can get snappy with. There's really only 3 functions you need to use: the correlation function, the average function, and the standard deviation .s function. Is it still unlocked out there, or did you bust it down?
It's like
props. All right, good. Yeah,
best props. Where do you find this Sakai Excel?
You open the assignment,
yeah,
right where it says before you click begin assignment, there's a link for that. I imagine if you go to table of contents, it might be there as well. But if you start the assignment, for me, it looks a little different than yours since I have to select from a whole bunch of different menus. But when I preview it, I get to this screen before I hit begin assessment. You got a link right there?
Yeah, I got it. Thank you.
Okay, yep. So that's the Excel we need. Now also on here, there are a list of the true-false questions. So for example, that first, we have there, question 1 says a scatter diagram is a graph that portrays the correlations between a dependent variable and an independent variable. And that's the same thing that we see here. So yeah, like I said, chase cutting. It only took me 4 minutes to cut to the chase. We can see the answer to this one is true. And that's effectively what a scatter diagram is. A scatter diagram or a scatter plot. That's what we've been looking at. That's when you put the dots on there. Different from a dot plot, don't call it a dot plot. A dot plot is like a histogram, but with dots instead of hists. I'm going to miss you later. You always seem to get the jokes. 2. An economist is interested in predicting unemployment based on GDP. Since the economist is predicting unemployment, the independent variable is GDP. So I'm using GDP to predict unemployment. True or false? The independent variable is GDP. True. GDP predicts unemployment. GDP is the right answer. It's true. What do we got? 101? 2 down, 101 to go. 3. agree. The strength of the correlation between two variables depends on the sign. Does the strength depend on the sign? Who says true? The strength depends on the sign. I said, who says true? The strength depends on the sign. No takers? Who says false? That's a lot of hands. Good work, y'all. Maybe you already saw the answer. I don't know. Maybe you just know. But yeah, R is kind of like Z in that regard. It has a direction and a magnitude. Oh, it's not true. It's false. Sometimes a false and true are switched, or all the time false and true are switched. Seems hypothetical. For none of us have we encountered the coefficient of determination. The coefficient of determination is otherwise known as R squared or R squared, depending on whether or not you like D's at the end of words. R squared is the coefficient of determination. The coefficient of determination is the proportion of total variation in Y that is explained by X. We haven't defined that. That's part of Wednesday after the quiz. I hope that says true, because that's the definition of the coefficient of determination. R squared is the last thing we talk about. We'll talk about that Wednesday afternoon. That's for the day school students. For the for Liv and Steve and anybody else who's been on that wonky Wednesday schedule with me, we're gonna have a hodgepodge Wednesday. We got a lot of different things to cover, but that's that. All right, Matt. Just in case I wonder, I can't tell if you're waving at me, so please be ostensibly waving when you are. You all right?
Yeah.
All right, good. Yeah. All right, good. 5. Coefficient of determination is the square root of the coefficient of correlation. So the coefficient of determination is R squared. That's all right. Coefficient of correlation is R. Is R squared the square root of R? Is that the square root of R? Is that the square root of R? Colin, what is it? What is this? Which is not the square root of R, because that's the square root of R. Yeah, so false. 6, one assumption underlying linear regression is that X values are normally distributed. We didn't talk a lot about the assumptions for linear regression, but that is not one of them. That is not one of them. Your independent variable does not need to be normally distributed. So 6 is false. 7. A and B are called regression coefficients in the linear regression equation. A and B are called regression coefficients. What do you say? Stephen says true. Stephen, right? Stephen, right? Billy agrees. Yeah, I agree too. A, B are regression coefficients. 8. The regression equation, which is y hat equals a plus bx, is used to estimate the value of the dependent variable y, sounds good, based on a selected value of the independent variable x. Says true. Says false. All right, that's only like a third of you voting, 2/3 of you have abstained. This is not Jeff gives you the answers. I'll let you think about it a little more. Y hat is a predicted value of y. Y hat is equal to, that's what this line symbol means. See that? It means equal to. The predicted value of y is equal to a plus b times x, which is the regression equation. And it is used to estimate a value of y based on some value of x. So who says true? Who says false? Momentum towards true carries the weight. True. Number 9. Because the coefficient of determination is expressed as a percent, its value is between 0% and 100%. And we haven't talked about R squared, but R squared is the proportion or percentage of variance explained by X, the variance in Y explained by X. When you take a value which is R, ranges from -1 to +1, and you square it, you always end up with the positive results. At most, it's 1, because 1 squared or -1 squared, either one of those equals 1. 1 is otherwise known as 100%. So in fact, R squared, the coefficient of determination, is a value which ranges from 0% to 100% true. What is the range of values for R? The low end and the high end, Katie? C. -1 to +1 inclusive. Looks good to me. And the answer key. 10 down, 91 to go. Okay. If the coefficient between two variables, x and y, is 0, what do we know about x and y? The correlation of x and y is 0. What do we know about x and y? If r equals 0, or if rho equals 0. And that's what we say if the correlation coefficient between two variables is 0. Do we know that variables are dependent on each other, such as one causes the other? Could it be that x causes y? Well, shoot, A and B say the same thing. The variables are highly related. The variables are not related. Yeah, I like not related too. 11 down, 90 to go. This is great time. We're some 13 minutes in, 10% done. We might actually get this done in 2 hours. You know what? I'm tired of this staple. We are on 12. 12. Looks like that, sort of. Brilliant. If we reject the null, now this is the null hypothesis for correlations. We have 2 options. If this is our null, we have a research hypothesis which says rho does not equal 0. We just got done saying if rho equals 0, the variables are not related. What's the opposite of not related? What's that, Chris?
Related.
Yeah, related. So this means they are related. If we reject the null, what can we conclude about the population correlation rho? Could it be 0? I don't think so because we rejected that. It does not equal 0. It could be 0. It is 0. The correlation is greater than 0. I kind of like that one. It is equal to the computed sample correlation. Could be that one. Oh, it is not 0. So what do we conclude when we reject this? What do we conclude about rho?
It is not 0.
Yeah. Do you go on more? Go on.
It's not 0 if we don't know if it's negative or positive.
We cannot
C.
use that one because it could be negative. And it's not necessarily the sample correlation. Bingo. Good. All right. 13(1)(3). In the regression equation, what does A represent? A represents Tiffany. The y-intercepts. A is in fact the y-intercepts. Answer is A. In the regression equation, what does B represent? Joe.
Slope of the line.
Very good. Now please be mindful that if you have seen this equation, it's silly because in that case, B is the y-intercepts, but it's not the same as we decided to swap out that for that. Slope of the line, B. 14 down, 80 some to go. In the regression equation, what does x represent? X is Billy?
Independent variable.
Independent variable. X is the independent variable. It's the input variable. So if I have y hat equals a plus bx, I'm going to put an input there, combine it with my regression coefficients, and come up with a predicted value for y. 15 down, 86 to go. In the regression equation, what does y represent? Column. Dependent variable. X is the independent or input. Y is dependent. Cool. What are the degrees of freedom used to test the significance of correlation? Megan? N-2. In the past, it has been N-1, but that's for univariate statistics. If we're comparing one mean to another mean, or one proportion to another proportion, we're talking about proportion of a particular whole, or an average of a particular sample. But in the case of a correlation, we have two variables, a bivariate relationship. Degrees of freedom is N-2. And that's listed on the answer sheet as option E. Cool, 17 down, some to go. All right, X's and Y's. Which is the independent variable? All right, it's time to get to Excel. So if you got that Excel stuff handy, that's where we're running next, is we're gonna do some Excel stuff up here and basically solve the problem. If you've got the questions handy, you'll see what the questions are. But the same way that the hypothesis testing questions have been designed to walk you through mentally what stuff you need to solve for step by step, that's the same questions that we're going to see over and over for each of these. As we can see, we need answers to the question, what's the independent variable? What's the dependent variable? What's the nature of the relation? And that's where we interpret R. We say, what is the value of the correlation coefficient? Well, that's we have to calculate R. Then we've got to know the coefficient of determination. That's where we take R and square it. We've got to know the t-value of the test statistic for the hypothesis test, which means we have to use this formula. But by that time, we will have the correlation of sample size as well as the coefficient of determination. What else do we need for these problems? We solve for B, we solve for A, then we predict y hat if x equals 7. And that's 9 parts for each problem. And that's how we roll. Those are the 9 questions. So let me just write those down real quick. That way we know exactly what we're doing for each of these problems. So A is what's the independent variable. B, what is the dependent variable. C, say what is the nature of the relation. D, we're looking for what is R. E, say what is R squared. F, what's the T statistic. G, what is B? Wow, now it's starting to get weird looking. H, what is A? I, what is Y hat? Given X equals 7. And I'm pretty sure that's what it is for all of them. I'm pretty sure I was like X equals 7 from here on out, if I remember writing this assignment, but it was August. So somebody correct me if I use the wrong value for X, but it seems like the path of least resistance was just to call X 7. Plant the flag, declare victory, move on, shall we? All right, so we have these 5 dots are plotted right here. Question 1, which is the independent variable? Well, we can tell the independent variable because it's on the y-axis, and I'm not a jerk, and I wouldn't call the x variable y and the y variable x. So A asks, which is the independent variable? Which is the independent variable? X, y, or cannot be determined. Tiffany? X. Horizontal axis, x is the independent variable. Which one's the dependent variable? It's got to be the other one. Y. Yep. Time to come up with the nature of the relationship. Nature of the relation. We're going to calculate R to make that happen. And given that you've already got the dots up here, to be honest, we could, and we will, do it the easy way. But I just want to come up with what the correlation between these things are. Sorry, what the correlation between these things are. R is the correlation between that and that. 0.75. That's my correlation. And I got there just by saying, what's the correlation? So for question C, we got 6 options. Weak and negative, weak and positive, non-existent, strong and positive, strong and negative, or perfect. A correlation coefficient of 0.75, what are we calling that one? Jack? Positive. Strong and positive. Just like you, my friend. Well done. All right. 20, strong and positive, D. 21, what is the value of the correlation coefficient? What do you say? What do you say? 0.75. What is the value of the coefficient of determination? Anybody remember how to calculate the coefficient of determination?
You just square it.
Yeah, I'm going to square R. Call it. Sometimes people will actually capitalize this R. Sometimes it's convention. What I'm going to do is that, get a number that I can convert to percent. These are decimals on your answer sheet, but I bet you can find one on here that looks like 57%. Which one's 57%? E. E? All right. Aaron says E. I choose E. Seems easy. Oh, golly. What is the t-value for the test statistic of a hypothesis test? That's 23. That would be using this formula. What's my value for R? 0.75. What's my value for N? How many observations do I have here? 5 observations. 1, 2, 3, 4, 5. I know that if you look at this table here, it may look like there's 10 numbers because we got 5 values for X and 5 values for Y. But if you look at the dots, look at the scatter plot, there are 5 dots, 5 observations. So R is 0.75, N is 5. That means your test statistic T is 0.75 times the square root of 5 minus 2 divided by 1 minus R squared, which we said is 0.57. 0.75 times the square root of 3 divided by the square root of 0.43. Looks like a mess. Why don't I use the computer? T equals R times square root of 3, because it's n minus 2, divided by square root of 1 minus R squared. Double check. I get a value that looks like it's around 1.98. By the way, your t-value is positive when your correlation is positive. Your t-value is negative when your correlation is negative. We get a positive correlation, we should have a positive t-value. I calculated a t-value of 1.977483469 L. Does that answer given to us in our answer sheet? We got one that looks like 1.9774836. Which one is that? Kyle says B. That looks like 1.98. I'll believe that. Okay. Given y hat equals a plus bx, we got to calculate a value for b. There's a couple of ways we can go about doing this. Now this is homework help. I can help you do the homework. I can help you prepare for what it takes to execute these problems on something like a quiz. So in order to calculate the coefficients appropriate, there are 5 pieces of information that I need. X bar and its standard deviation, Y bar and its standard deviation, and the correlation coefficient, which I've already determined is 0.75. I got to calculate those things from here. So I want to take the average of those numbers, and I want to take the standard deviation of those numbers. Use Excel because it's quick. Now we've got inputs. The mean of x is 5.6, the standard deviation of x. And I used the sample standard deviation formula here because we need s sub x. The mean of y is 5.8. Standard deviation of y is 1.3. So we can use Excel to gather this information. The first 2 questions we asked and answered. What's the independent variable and what's the dependent variable? We know that in this example, x is the independent variable, but x is always the independent variable. The horizontal axis, as we talked about in here, x is the independent variable and it predicts the y. This is our independent variable, our dependent variable. 1, solve for b. 2, solve for a. 3, y hat equals bx, and I believe we're saying x equals 7. That's the formula for r, or for b. R times the standard deviation of y over standard deviation of x. S sub y is 1.3. S sub x is 2.7. So I'm going to guess you get a value of something around 0.38. You can use a calculator to come up with b. A. Require some input too. I got to make sure I'm not going too fast or I'm going to miss something up. Happens. That should be B. What do we get up here? What do we get for half of 0.75? 0.36? 0.36? 0.36? I'll buy it. Y bar minus B times X bar. So that's our value for B. This is our value for A. Third of 56. Something like 19, 1.9. Then we take 1.9 away from, should be a number like 3.9 or 3.8. What do you get for A? 3.78? Sounds like 3.8 to me. Ish. Now the numbers you might get on a sheet like this could be slightly different. For example, what is the value for B? What is the value for B? 3.7, no, 6.2. Oh, 0.36. we go. What is the value for A? Something like 3.8. You see a value that's 3.77. I notice up here, this is the only one that's even close to what mine could be. 3.77 and 3.49. Both of those are close to what mine could be. This one's obviously right. So for 24 and 25, that's what we got from DNA. Now we got to come up with y hat if x equals y. Or x equals 7. Y hat equals A, which is 3.8, plus B, which is 0.36, times x, which is 7. 42, 21, 2.52, 52, so 6.32. That's what I got. What do you get? Oh, I got 6.31. That's just doing arithmetic here. 7 times 0.3 is 2.1. 7 times 6.42, 2.1, plus 0.42 is 2.52, plus 3.8. It's going to be 6 and change, like 6.3 and change. So approximately 6.3. And that's part 2, x's and y. We're going to move on to question 27 in a minute, but I want to do that other question again first. I know, you look confused. I'll show you why. Any questions on that first example? Pretty straightforward. I'm going to right click the dot. I'm going to say add trend line. It adds a trend line. I'm going to say display equation on chart. Display r squared on chart. And I'm going to make it big. And I'm going to change the font because default fonts are boring. How about that one? And wouldn't you know, all this work that we had to do by hand, there's my 0.36, there's my 0.36, there's my 3.8, and there's my 3.8. There's my r squared of 57%. You can take the square root of that and find yourself an r. It won't tell you if it's positive or negative. Those dots will. So if you want a shortcut to success, here's my recommendation. Add a trend line and insert your r squared. Take the square root of r squared and you get r. You have to decide from the square root of the coefficient of determination whether that's positive or negative, but you don't have to use the correlation function. You don't have to calculate a mean or a standard deviation to do any of these problems on homework. If you're bright and you're proficient in Excel, you can knock these problems out in a couple minutes, to be honest. And I'm going to do a couple problems that way. I still want to demonstrate a little bit doing it on paper because, again, that's the part I want to get you in the habit of. I want to give you some behaviors to model. But if you really want to shortcut it, you insert the trend line, you add your equation, you get your r squared, take the square root of that, get an r. That answers every question on here, except for the interpretation ones. So we're going to move on to this problem. Any new questions now that I've showed you how to get it done? All right. Question 27. Let's make this a little bigger. look like a positive or a negative relationship there? Positive, negative,
Negative.
mm-hmm. Strong or weak?
I would say strong.
What tells you that it's strong?
The dots are kind of close together.
Yeah. Good interpretation. The strength of the correlation doesn't have so much to do with the fact that it may be steep or it may not. It's not like your black diamond slope or anything like that. That's not what we're concerned about. We're concerned about whether or not it's close together in terms of those dots. If those dots are all over the place and it looks like a shotgun blast, that's not a good correlation. This variable x is on the horizontal axis. This variable y is on the vertical axis. Question 27, which one is the independent variable? X, y, or cannot be determined? X. Which is the dependent variable? Y. What is the nature of the relation? Matt already told us.
Strong and negative.
Strong and negative. What's the value of the correlation coefficient? You shouldn't even have to do any math for this one. Given the options of negative 0.89, positive 0.21, positive 0.79, and positive 0.11, only one of those is reasonable. Which one's reasonable? Negative 0.89, and it's reasonable because it's the only negative correlation there. 30 down, 71 to go. 31, what is the coefficient of determination? Well, you take 0.9 and you square it, and you get 81%. You take a little less than 0.9 and square it, you're going to get a little less than 81%. And I need a different page for that. So 0.79, 0.21, 0.11, and negative 0.89, which of those is closest to 0.9 squared? 0.79. And if you take negative 0.89 and square it, you should get 0.79. If you insert the trend line and say display r squared on this picture, you're going to get 79%. Ooh, we have two choices for a t-value, which we can calculate here. T-value says, give me r times the square root of n minus 2 divided by 1 minus square root of 1 minus r squared. Sounds like we've got a lot of calculation to do here. But we've got two choices for a t-value, negative 4.8 and positive 4.8. Which of those two is the value for our test statistic and why? Tiffany. Yeah, very good. Those who didn't hear Tiffany, she said the correlation is negative and strong, so our t-value as well should be negative. I'll leave it as an exercise to you if you want to calculate that t-value. But a negative correlation means a negative t-value. A positive correlation means a positive t-value. Similar to when we did hypothesis tests for mu and for pi, and we had to calculate test statistics. If you had a positive difference between what you observe and you expect, you end up with a positive z or t statistic. If you have a negative difference between what you observe and expect, you have a negative t or z statistic. 32, the answer is A. 33, part G. Y hat equals A plus BX. What's the value for B? Well, we take that correlation coefficient, negative 0.79. We multiply it times the standard deviation y and divided by the standard deviation x. There are only two options of these four. Which could it possibly be? It's either negative 1.74 or negative 0.45. Because the slope of the line which fits these dots is negative. So B has to be negative. There's only two choices there. Who wants me to use the formula, and who wants me to click Excel? Who wants me to use the formula? Who wants me to click Excel? I got hands for Excel. I'm going to use the formula. And then use Excel to check my work. But I got to use Excel first to get these values. I need the average of these. By the way, I'm going to start here, hold control, hold shift. I'm now holding control and shift. When I hit up, it goes too far. I let go of control, still hold shift, press down, and I have highlighted that section. So when I highlight this stuff real fast, it's just getting used to what control and shift do. What they do. But they do. Now I'm going to copy this formula, control C, come over here, control V. Now I have the average for both X and Y. Now I need the standard deviation for both of those. ST, drop down to, same pattern, copy, move it. I have standard deviations for both of those. That'll play. I already determined earlier that R is negative 0.89. X bar, the average of X, 4.9. Standard deviation of X, 1.7. Y bar, the average of Y is 10.6. Standard deviation of Y is 3.4. The 5 pieces of information I need. 1, calculate B. Remember when you calculate the slope? If I say rise over run, perhaps you remember that from calculating slope. Perhaps that gives you some horrible flashbacks to pre-algebra and I don't know, that 5 years ago it was when you were learning that stuff. As it were, S sub y over S sub x. Again, it's y over x, rise over run. S sub y over S sub x, that's just a scaling factor in case one of them happens to be wider than the other. R is negative 0.89, S sub y 3.4, S sub x 1.7. That to me says, of these options right here, I'm pointing to the correct one. Because that appears to be, no, I was lying. That appears to be the correct one. Because that looks like 2, that looks like 0.9. Something around there. Hey, it says the answer is A. How you calculate B? Step 2, calculate A. A is y bar minus B times x bar. Y bar, 10.6. B is negative 1.78. More pre-algebraic flashbacks. If you subtract a negative, you're adding. I feel like you cats that have been through some accounting stuff where adding and subtracting debits and credits and things, if I just put parentheses around them, meaning they were negative, or had a red pen and I could say that, it might be a little bit more familiar to you. Perhaps. Maybe not. Maybe you just know that 10.6 is going to be plus, but we got X bar in here, 4.9. 1.78 is about 9 out of 5. I'm going to say that's 10.6 minus 9, or something around 1.6. That's my rough guess. Here's my answer key. Value for A is the y-intercepts, 19.1. Where did I go wrong? Because minus and minus means plus. So I actually get a value here of something around 9. By the way, what do you get when you get 1.78 times 4.9? What is 1.78 times 4.9? 8.72. kind of like 9. When it's multiple choice, don't waste your time with all that rounding. Find something that's close. 10.6 minus means plus, so it's 10.6 plus 8.72. Value for A, something around 19. Now we say if y hat equals A, which is 19.1, plus B, another our answer to B should be something like that, negative 1.74. If x is 7, 19.1 plus a negative 1.74 times 7. That's a half and a 7 and a 3.5. I feel like I want to take 19 and subtract about 11. It sounds like it should be near 8, but I don't know. I don't know about that one. I feel like I'm wrong there. It should be more than that. 12.9818? 12.18? Confirm, Chris?
Yeah, 12.1.
12.1, 12.4, something around there? Or here?
Yeah.
Yeah, okay. 19.1 minus, we can call it 12.4. 1 or 2, doesn't matter. Basically taking 19 minus 12, so it should be something around 7. And of these options here, only one of them is around 7. There's more explicit rounding instructions on your quizzes. If you take a look at that, you'll see. Besides, you've got Excel here to do all this work for you. You should be able to get more than half of the questions right just by looking at the picture here. Right-click a dot, say add trend line, click a couple boxes, drag as you see fit. Okay. Hey. What are you doing? There's too many dots on here. There we go. That feels more comfortable. Yeah, so be mindful of where you add your, be mindful of where you add your summary statistics. If you put it in the same column below, Excel might put dots on your picture. Puts dots on your picture, it's going to give you a different regression line. Gives you a different regression line, then you're going to panic in front of the students in your classroom. Or, I don't know, more important places. Anyway, that gets you most of the way there. Part 3 down, 35 down, 66 to go. We're not even an hour through. All right. Now we're going to talk about Celtronics. We've got to define the independent and the dependent variable. And here's the scenario. It's like we have 5 observations. The production department of Celtronics International wants to explore the relationship between the number of employees who assemble a subassembly and the number of subassemblies produced. So we've got widgets and we've got people. One of those is the independent variable, one of those is the dependent variable. Does the number of widgets depend on the number of workers, or does the number of workers depend on the number of widgets that those numbers produced? Which one is the independent and which one is the dependent variable? So what? That's correct. Assemblers are the independent, and the widgets, whatever they are, the subassemblies, is the dependent variable. Number of assemblers, that's X. The amount produced is Y. The independent variable is assemblers. Ah, that's why you said assemblers. Good. And the dependent variable is the production. So 36 is B, 37 is A. I look at that picture. What do you suppose the nature of that relation is? Billy?
Strong and positive.
Strong and positive. It's certainly positive. There's only a couple of observations, though. Maybe it can be tough to decide whether it's strong, but we can definitely see. Oh, cut to the chase. Because once you have this, life is so much easier. R squared is 0.86. Square root of 0.86 has got to be at least 0.9. I should have brought a real mouse. Anyway, I'll read the second sentence of the question now. As an experiment, 2 employees were assigned to assemble the sub-assemblies. They produced 15 during a 1-hour period, represented by this experiment. Then, 4 employees assembled them and made 25 widgets. They produced 25 during a 1-hour period. Already said that. The complete set of paired observation follows below. X is the independent. Y is the dependent. It's a strong and positive correlation. That means positive. That means strong. What is the value of the correlation coefficient? Well, it doesn't. We have 0.14, 0.92, negative 0.92. I'm going to eliminate negative 0.92 because that's not positive. And 0.86. You know what? I'm going to eliminate 0.14 as well because 0.14 is a small value. So it's either 0.86 or 0.92. Billy, what do you think? 0.86 or 0.92? 0.86. Why do you say 0.86? What is that value? Is that the coefficient? Is that the correlation coefficient? 0.92, yeah. This value is not your correlation. This is R squared, which is 0.86. This is called your coefficient of determination. Part E, Billy, what's the value of the coefficient of determination?
0.86.
Yeah, thank you. So R is 0.92. R squared is 0.86. 40 down, 61 to go. Cruising. T-value, is our T-value going to be positive or negative? Positive 4.29 or negative 4.29? Hit me in the face, Kyle. Positive. Now we got to come up with B and A. I know that the line provided for me here has things in a different order. This is still y equals bx plus a, not ax plus b. B hangs out with x. A hangs out alone. A is articles of 1. It's indefinite. B hangs out with x. So, what's the value for B? B hangs out with x. What's the value for B? Megan? 7. A. Sorry, it's A on the answer. Pick A. It's got 7 next to it. That's hard to explain. Just pick 7. You decide what button to push. 43, what's the value for A? The value for A is the one that's hanging out by itself. A hangs out by itself, like Aaron's about to. I don't think he's hanging out by himself. Reynolds. 3. Yeah, pick 3. Okay. Solve for y. X equals 7. 7 times 7 plus 3 equals 52. Choose the letter B. 44 down, 57 to go. Questions on Celltronics? We good? All right. I'm going to start dragging this out because this is our last homework help session. And then when there's no more homework help sessions, what am I going to do? What can I possibly do with my Monday night with no more homework help sessions, except dream about the homework help sessions? I'm going to be sad. What are you going to do with your Monday nights? That's the question. Some of you taking the test. All right. Let's talk about crime. It's funny. I think that's actually, I don't know where that is. It's probably Ohio. I think at least one of these authors from this textbook is from Ohio. We're talking about crime. In this case, the City Council of Pine Bluffs is considering increasing the number of police in an effort to reduce crime. If there is a negative relationship between the number of police and the amount of crime, then maybe it's a good idea. Before making a final decision, the council asked the chief of police to survey other cities of similar size to determine the relationship between the number of police and the number of crimes reported. If anybody wants to get critical or cynical here, notice that the word reported is used once. You're certainly going to report crimes if we got more cops. Doesn't mean there's necessarily fewer crimes. Anyway, the chief gathered the following sample information. Number of crimes reported, because you can't really calculate statistics for crimes which are not reported. And police. Police is on the horizontal axis. Number of crimes reported is on the y-axis. 45, which is the independent variable? Police. Horizontal axis is their independent variable. We want to know if the number of police determines crime. 45 is police. 46 is crime. 47. What is the nature of this relationship? Strong and negative. Strong and negative. Yeah. I mean, I think it's strong. It's very clear. And the reason we can get away with strong on most of these where there is a relationship is not because this is necessarily like a super strong relationship, but it is. If you can see the relationship and there's only 8 data points, that means that the relationship must be strong. If it were a moderate relationship or even a weak relationship, you probably wouldn't be able to detect it with only 8 data points. The only types of relationships you're going to be able to detect with your eye with a few data points are strong relationships. And in this case, it's strong and negative. Okay, we got 4 choices for the value of the correlation coefficient. 2 are positive and 2 are negative. Does that work? Kind of. 2 are positive and 2 are negative. Which one are we going with for the answer to 48? Stephen, you say A. Why do you say A? Yeah, because it's negative and strong. There you go. 48 down, 53 to go. So negative 0.87 is our correlation coefficient. You take 8, 7, and you square it, or negative 0.87, and you square it, and you get the coefficient of determination. I would immediately eliminate Bravo and Delta because those are negative values, and the coefficient of determination cannot be negative. It's a positive value ranging from 0% to 100%. So what do you say here? What do you say, Liv? A, 0.76. Let's get Excel to provide the confirmation. Add a trend line, give me the equation, give me the r squared. Hey, you're right. Well done, though. It also means we now have values for both B and A. Oh, we have to decide whether our t value is positive or negative. Is the t value positive or negative here? Megan? Why negative? Yeah, negative r means that will always be negative. Click aside on that portion. There you go. There you are. This is the formula to calculate our test statistic t. R can be positive or negative. The square root of your degrees of freedom is always positive. The square root of 1 minus r squared is always positive. That's always positive. That's always positive. The only thing that can be positive or negative to affect the sign of t is r. Because r is the only thing which can be positive or negative, which is why r determines the sign of t. Negative 4.41 is my t value. My value for B, I got a couple things on there. A couple values which look pretty close. I got 29.4 or 29.6. Which one am I going with? So B is 29.4. This is where I do shifty eyes and I realize you can't see shifty eyes because I'm staring into the sun. Tiffany, what's wrong with me? That's the value of A because A hangs out alone. B hangs out with X. So for question 51 where we're looking for B, A hangs out alone. B hangs out with X. Our slope should be negative because our correlation is negative. Negative 0.96 is the value for B. So we want 51C. At 52, we're going to come up with a value for A. And in this case, 29.4 sounds right. A hangs out alone, B hangs out with X. A hangs out alone, 29.4. B hangs out with X. The answer to 52 is A. All right. Solve this. If X equals 7, there are 7 police officers. How many crimes do you think there will be? Now we're going to start being able to do this visually. We don't even have to solve for it. We have 3 options. Something like 23, something like 205, and something like 61. Those are the 3 options. 23, 200, 36. If this regression line allowed us to extrapolate for 7 cops, something around here, something around 25 is the number of crimes which would be committed. That rules out 205 to me. And while my ability to draw a line and know exactly where 7 is, which is something like here, I think that that number, which is 23, is a lot more reasonable than a number like 36. So I'm not trying to skip over what it takes to pull out the essential information, substitute it into a formula. But in this case, that's absolutely pre-algebra. At this point, we should be quick enough to be able to use the tools which are available to make this as efficient as possible. Excel, to drop a regression line on a scatter plot, and then interpolate from that picture what the answer to a question is, such as if X is 7, yeah, Y is going to be something like 22. In this case, 22.7. Choose A. 53 down, 48 to go. But that's also quicker. That's also reading a graph. It's also what you'll likely be doing when you're moving forward. You're still going to calculate numbers and such. This is the easiest way to do it. And you have the option here. We do this stuff in class tomorrow and on Wednesday. Have plenty more opportunity to run through those 3 steps. But it's 3 steps: solve for B, solve for A, and plug in X. That's part 5. Part 6, we're talking about Maumee. Now, Maumee's a beautiful town, but they got a rat problem right now. They had a lot of flooding out there earlier this year. My mom and my aunt used to work at this car factory. There's a big GM factory out there. Everybody in that town, because that's a suburb of Detroit, Motor City. Lots of cars used to get built out there. My mom she typed a bunch. My Aunt Lori, my Uncle Carl. Told my Uncle Carl. He's the 3rd cyborg. Anyway, they all work there. The owner of Maumee Ford Mercury Volvo wants to study the relationship between the age of a car and its selling price. Can't really tell what that relationship is. Anybody want to take a stab at what that relationship is? Matt?
Weak and positive.
Weak and positive. Sort of looks like we're supposed to have an arrow pointing to this one, but I mean, that's sort of low, and you've got the age and the selling price. It's kind of a young car to have that. Okay, let's see. Listed below is a random sample of 12 used cars sold at the dealership during last year. Oh, this isn't the factory. This is the dealership. No, they never worked at the dealership. They worked at the factory. Anyway, 54, what's the independent variable? Independent variable is going to be the variable on the x-axis. What's the independent variable? Age. 54 is age. What's the dependent variable on the y-axis? Selling price. B. What is the nature of the relation? Now, it's a little bit tougher. Now, Matt spies with his little eye what he appears to see as a, what did you say?
Weak and positive.
Weak and positive correlation. But if we add a trend line and put that stuff on here, I see that R squared is 0.01. How do we get to 0.01? Square root of 0.01 is going to be 0.1. That means our R value is 0.1. I think 0.1 is what I've been told in my experience is sort of the perception threshold. Anything less than 0.1 and you can't even notice it. Around 0.1, you might be able to notice it. There's only 12 observations here. A correlation of 0.1, which is effectively what we have here. The correlation between the age and the selling price of 0.1 is not very large. I would contend that this one is in fact non-existent. And that's what I'm telling you it is. In order to get at least to weak, we got to see something around 0.2, maybe 0.25. Or at least if we want to say that this is a real correlation, positive at all, we would need many more observations in order to draw that conclusion. But right now, with an R squared of 0.01, that means that 99% of the variability in the car price is left unexplained. Only 1% of the variability in car price is explained by its age. That's us interpreting R squared beyond it's just R value squared. There's lots of other things which explain the selling price and probably do so much better than the age of the car. The relationship between the age of the car, selling price, B, non-existent. Because when we calculate the correlation coefficient, the value is 0.1. We have here. The value of the correlation coefficient is 0.1. Not very large. The value of the test statistic is either negative 0.32 or positive 0.32. Which one of those is it going to be? Negative or positive? What'd you say, Steve? Positive. Why is it positive? Why is T positive? Yeah, T is positive because R is positive. If we were to conduct a hypothesis test at any significance level that matters, we would accept the null. Because a test statistic of 0.32, which is what we calculate our t-value to be, will never be in the region of rejection. 0.32 means what we observe and what we expect are very similar. What we observe in this case, 0.1, and what we expect for a non-existent correlation, 0, those two things are very close. So that's again why we would conclude that this correlation is non-existent. $59 is B. 42 to go. G, part 6G, given that regression equation, which is the value for B? See two values which are pretty close. Just make this a little bigger. Put all through C, like Lady Macbeth. So what's my value for B? What'd you say? That's not what I'm pointing to, Stephen. Thank you. A travels alone, B travels with X. 0.0647 is the value for B. The slope is just about 0. I would choose 0.064, even though that might suggest it's 0.65. A, I think 6.4 sounds pretty good. So we're choosing the value for A is again, 60 is A, 61 is also A. Both of those say the value for A is about 6.4. Actually, no, that's not right. I mean, it is right. They're both, the answer is A. But for 60, the value for B, the y-intercept, is the number next to A. We've been over this, 0.064. It's the value for B. Then if we put 7 in here, and we want to solve for what would effectively, bless you, be y hat. Look at this. Look at the value for the slope. 0.0647. If you had $0.0647 in your pocket, how many dollars in your pocket do you have? Effectively? 0. Look at the slope as being 0. If I put 7 equals x here, I'm effectively taking 0 times 7, and 0 times 7, Chris? 0 again. So we're going to look for a value that's probably close to the y-intercept of something about 6.4. Maybe a little bit more than that. 62, what is the value for y hat if x equals 7? It's going to be a touch more than 6.4. 6.8, 45, or just under 6. Which one of those is it? Which one of those is a touch more than 6.4? 6.8. Thank you, Chris. All right, 62 down. Throat lozenge, go. Where are we at in time? 6:18. So we're on pace to knock this out by 7 o'clock. I honestly think this is a more effective use of our time, getting used to thinking about how to assess these problems quickly. using the tool you have available. Anybody wants me to walk through one of these by hand, show you how to do B equals, A equals, and so on, feel free. Stop me and slow me down. I got no problem doing it that way. Did a couple of them that way, but I think this is the right way to do it. Okay, part 7. We got 5 parts to go. We got 42 minutes to do it. On our horses, ladies and gentlemen. We're talking about heating a house. Bradford Electric Illuminating Company is studying the relationship between kilowatt hours, or basically electrics used, and the number of rooms in a private single-family residence. A sample of 10 homes yielded the following information. One of these is the independent, and one is the dependent. Does the amount of electricity used depend on the number of people living there, or does the number of people living there depend on the amount of electricity used? Let's see. Part 7, heating some rooms. Independent variable, kilowatt hours or the number of rooms? What's the independent variable? Number of rooms. The horizontal axis, X. Number of rooms, that tells you how much power is used. 64, what is the dependent variable? Kilowatt hours. Rooms, hours. 64 down, 37 to go. We got more than a minute of problem. I can take my time. What is the nature of this here relationship? We have 10 dots. And that's pretty clear to me, Kyle. Strong and positive. There you go. Crack my whip. Let's go, Kyle says. I'm going to raise my hand to get this done. Now he's going to waste all that time that I saved by talking about it. Yeah, I ruin wonderful things. I appreciate the effort. You want to keep me moving, you raise that hand again. Sound good?
Sounds good.
Okay. Kyle said that the answer to 65 is strong positive B. All right. 7D. What is the value of the correlation coefficient? Is it 0.09? Is it 0.91, 0.18, or 0.82? All right. 2 of those are strong and positive. 2 of those are not. So it's either 0.91 or 0.82. Let's find out. Thanks, Ken. Add trend line. Get that stuff up there. Make big. I see a value of 0.82. Does that mean my correlation coefficient is 0.82? What do you think? What do you think? No, why not? What is 0.82 equal to? There's a 3-word term. Exactly. R squared 0.82 is the coefficient of determination. That means that the strong positive correlation is not 0.82, but rather the square root of 0.82, which is B, 0.91. 67. What is the value of the coefficient of determination? Megan just told us, and that is 0.82. Oh, ooh. Now we have 3 options. We have 2 positive values for T, 1 negative value for T. It's time for us to decide which of those it could be. We appear to have a strong positive correlation. So we're going to have a positive T value, either 0.598 or 5.98. Which of those T values is more indicative of a real correlation, Matt? 5.98. I concur. The bigger the T value, the more evidence you have to reject the null. The more evidence you have to reject the idea that the correlation is not real. Big R, big T. Big T, big R. Big R, big T. Goes that direction. R determines T, not the other way around. 68, the T value is 5.98. C. 69. Given that y hat equals a plus bx, what is the value for b? James?
2/3.
2/3, but I'm pointing at 4/3.
Let's say.
That's a what?
That's the A value.
Oh, that is a value. I know, because there are many values up here. This is one of them.
It's not the B value.
It's not the B value. All right, very good. Who's on first, right? I appreciate it. Well done. Yeah, no, I was pointing at A. A is 1.33, which is 4/3. But the value for B is 2/3. That's B, 0.67. That's A. But again, don't get confused because the answer to 69, which is looking for B, is A. And the answer for 70, which is looking for A, is B. Let's just remember that B is 0.67 and A is 1.3. It's up to you to decide which radio button to hit. Kosher? Thanks, Colin. I got 2 thumbs from him. I don't need anybody else's. 70 down, 31 to go. All right. If X is 7, we take 2/3 of 7 and we get 14/3. And then we add 4/3 to that and we get 18/3. 18/3 is otherwise known as 6. Yeah. Fractions are awesome. Sorry, James got me thinking about fractions, and fractions just made our life easier there. Yeah. This is 2/3 times 7 is 14/3. This is 4/3. 14/3 plus 4/3 is 18/3. 18/3 is 6. If X is 7, Y is 6. Hey, part done. Next. Part 8. Pick up. Oh, it would have been better had I zoomed in to begin with. Oh, it's shameful. Hey, you know what? I'm going to click on this and add the trend line while I'm over here. If y'all don't mind. I'm going to curse the fact that I don't have a mouse. Oh, that's a pretty big R square right there. Looks like whatever's happening is pretty important. All right, call, sales calls. Part 8. Mr. James McQuinney, president of Daniel James Financial Services. I would probably put my last name in the name of my financial services company, but that's just me. Yeah. Right? James, are you going to put your last name or your first name in the name of your financial services company?
I would put my last name. Because
Yeah.
most people call me McGuire. It's more memorable.
Yeah, no, I'm on board. I feel special because I don't call you what most people call you. Still don't call you James. All right, we're going to talk about what the Daniel McQuinney Financial Services Program believes. A relationship exists between the number of client contacts and the dollar amount of sales. To document this assertion, Mr. McQuinney gathered the following sample information. The X column indicates the number of client contacts last month, and the Y column shows the value of sales last month for each client sampled. The number of contacts, the number of sales. One of those is the independent, one of those is the dependent variable. Question 72. Which is the independent variable? Contacts or sales? 72? 3, 2, 1. Contacts. 73, which is the dependent variable? Sales. Okay. What is the very clear nature of this relation? Strong and positive. Ooh! I was wrong. Strong and positive is not the answer. Because there's a better answer. Almost perfect. Damn right, Billy. Because what is the value of the correlation coefficient? Looks like R squared is 0.95, so R is going to be the square root of 0.95. Got to be bigger than 0.95. What do we got? Square root of 0.95 gets you 0.98. F, 0.98. 75 down, 26 to go. Coefficient of determination. Let's go to the big board. Coefficient of determination, 0.95. Right there. Sounds good. If R is positive, which it is our t value 12.5 or negative 12.5? Positive 12.5. Yep. Positive R means positive t. Okay. Question 78. What is the value for B? See what I do there? I'm not tricking you? No. B travels with X, 2.19. Yeah, we got a value that looks like that, 78, 2.19. That's our answer. But again, I seem to like to put the answer A as the value for B. I don't want to go in that circle. Just pick 2.19. That's the value for B. Because the value for A is negative 12.201, which on your answer key is A, but A is A. All right, yeah, negative 12.201. That's A. 79 is A. 79 down, 22 to go. Given that if X equals 7, 2 times 7 is 14. 14 minus 12 is how many? This many. I have 3 choices for Y hats on my key. A negative 83, a positive 3, and a negative 27. Only one of those is remotely close to 2, and that would be 3. And again, if I said follow this line to where X equals 7, it's probably going to be somewhere around, even if I look at it visually, 0, it is certainly not somewhere down here around negative 20 or negative 30. Visually, extrapolating from this line, the only place near X equals 7, something near 0, not a big negative value. The answer to 80 is 3.16. 80 down, 21 to go. Questions on Mr. James McQuinney? No relation. Okay. Part 9, save that money. Oh, I guess we're still talking about Mr. James McQuinney of the Daniel James Financial Services Company. He's a popular guy. I wonder if I put a pun in here that I didn't remember. Is James McQuinney a real person? Anyone got that in their brain? All right.
Sounds like he was born before 1900.
Yeah. He definitely has like an ad in an old-timey rag, and it's like, come to the James McQuinney Services Company. Deposit your gold bullion, and it will be safe from the Confederate Army and the British. Anyway, he's still concerned about financial services, and he believes that there's a relationship between the number of client contacts and the dollar amount of sales. To document this assertion, Mr. McQuinney gathered the following set number of client contacts. That's not what we have here. What we have here is James McQuinney. You know what this is? That ain't right. What we have to do now is recognize that that was the same words from the last problem, but this is different data. So, Mr. James McQuinney of the Daniel James Financial Services Company believes that there is a relationship between the assets in millions of bonds in a portfolio and the return percent which is made from said bond. Doesn't matter what the words are at this point, because we know we're looking at some independent variable assets and return percent dependent. That's our X and that's our Y. This is effectively saying, am I going to get a higher return rate if I have more assets in a particular fund? Oh, I should have said fund because the column was labeled fund. If your table and your picture are labeled well enough, words are irrelevant. Your picture should speak for itself. Your table should also. I don't want to take words out of it. All right, 81. Which is the independent variable? Neither assets or the return percent. Assets, how do you know? It's the X, very good. Return percent should be your dependent variable because it's on the Y-axis. What's the nature of that relation? What do you think, Matt?
Non-existent.
Yeah, there doesn't appear to be any sort of trend there. By the way, for those of you keeping score at home, Control 5, strike out text. 5 looks like an S. Control 5 is like strikeout. Because 5 looks like an S. But anyway, if we right-click a dot, let's say add trend line, and we do that stuff, and we make that, oh gosh, there's no relationship at all. Look at that. R squared isn't even a percent. If someone said, what's R squared? You could say 0%. You could say the X variable predicts no variance. See, Joe? Predicts no variance in the outcome variable. Why? Okay. 83, non-existent relationship. What is the correlation coefficient? It's the square root of 0.0021. It's either negative 0.05 or 0. Well, you know what? I might need to calculate this one because that looks pretty close. The difference between negative 0.05 and an actual value of 0. Tell you what, I can't tell there. So, can anybody remind me of what the function is? Correlation. Tiffany? Yeah. And then highlight the what? Sounds good to me. Ooh, that does appear to be, we go back to that comment when we were talking about what correlation coefficient, thank you, Tiffany, what a correlation coefficient of 0.1 would be. In this case, we have negative 0.05. Again, that's practically 0, but if this question gives you negative 0.05 as an option, I think you pick negative 0.05 as the answer. Oh, and do that because it's the answer. It says it on the key. 85, the coefficient of determination, 0.0021. That certainly rounds to a whopping 0. 85D. 85 down, 16 to go. What is the t value for the hypothesis test? I gotta believe it's close to 0. 1.21 is not close to 0, but I have two other options which are not close to 0. One's positive and one's negative. Which one do I go with here? Yep, thanks, Katie. Going with the negative one. Only one of those is negative. They're both close to 0. Pick the -1. 86 down, just a couple to go. And then that overwhelming sense of ennui overwhelms us because it's overwhelming. And we don't know what to do with ourselves. What's the value for B? Am I tricking you? How do you know? How do you know I'm not tricking you? Yeah, because B likes to hang out with X. B is -0.0004. Closest value here for B. 88. Value for A. A hangs out by itself. 9.92. 89. If I take 0 times 7 and add 10 to it, I get a value close to 10. Given my choices of 0, 70, or 10, which one of those do I choose? Yeah, 9.92, aka, yeah, double nickels. Actually, that's 55. Let's get that right. Yeah, 10. Oh gosh, we're so close, so close. 10. Oh, darn it. Now we actually have to do a real hypothesis test. And we were going so well. Life was so good. We still got to do a hypothesis test. But hey, the hypotheses are already given to us here. And if these are it appears as though there are 1, 2, 3, 4, 5, 6 questions to answer. Looks as though we can do it. Okay. A regional commuter airline selected a random sample of 25 flights, 25, and found that the correlation between the number of passengers and the total weight in pounds of luggage stored in the luggage compartment is 0.94. Almost perfect. Hey, did you know that the more people on the plane, the more luggage there is? And given the fact that everybody tries to take as much as they can, but are not allowed to take any more than as much as they can, everybody brings about the same amount of weight with them when they travel on a plane. So it would make sense that the correlation between the number of people and the amount of weight on a plane is perfect. Time to come up with the value of the test statistic T. There are 2 inputs we need for T. They are R and N. What's the value for R that I have in this problem? The value for R is, we'll do my whole Hogan. 0.94. What's my value for N? 25. R, N. R is 0.94. N is 25. I'm going to use this formula to calculate my test statistic T, otherwise known as R times the square root of N minus 2 divided by, oh, big fat fingers, divided by the square root of 1 minus R squared. Gets me a test statistic around 13.2. That's me using Excel because it's a great calculator. I highly recommend it if you have the chance. The answer to 90, 13.2. That value there. Oh, golly, is this a directional or non-directional hypothesis? And how do you know? Directional or non-directional? Reynolds, how do you know? Yeah, which one's that? Yeah, it's got a greater than symbol. So it's directional hypothesis. How many tails are in a directional hypothesis? 1 tail is in a directional hypothesis. How many degrees of freedom do you have? Don't stop. 23 degrees of freedom. What's the critical value? All right, you can stop. We go to our table, get the critical value. When we got 23 degrees of freedom, we know it's a one-tailed test. Three things we need for a critical value: the number of tails, T or Z, and significance level. Significance level is given to us at 0.05. All right. Two tails, 0.05, 23. One tail, 0.05, 23. Y'all like that number? I like that number. Y'all like that number? I like that number. 1.714. That's our critical value. Survey says yes. Sorry. Hard for me to find that one I was looking for. 1.714. That's good. What do we got here, though? My critical value is, what did we say, 1.714. This value is also a T, but it's the critical value. This is my test T. Okay. My test statistic is greater than my critical value, so I reject the null. I accept the research hypothesis. Describe the nature of the relationship. Is it real? Yes. Is it perfect? Close. Is it negative? No. Is it positive? Yes. If we're going to describe the nature of this relationship, in order to answer question 95, the nature of the relationship, real and positive. A. 95, the answer is A. It's real and positive. 95 down, 6 to go. The Airline Passenger Association studied the relationship between the number of passengers on a particular flight and the cost of the flight. It seems logical that the more passengers on the flight result in more weight with more luggage, and will in turn result in higher fuel costs. For a sample of 15, that's 15 flights, the correlation between the number of passengers and the total fuel cost was 0.667. Test this at the 0.01 significance level. Look here. We have hypotheses as well. These hypotheses are based on the fact that the statement up there said, it seems logical that more passengers will result in more weight and more luggage and will result in higher fuel costs. We're looking at the correlation between the number of passengers and the fuel cost. And it is hypothesized to be positive. We hypothesize that the correlation is greater than 0, otherwise known as positive. 96, what is the value of the test statistic? In order to calculate a test statistic, we're going to use that formula. So the test statistic, T, requires two inputs, R and N. What's the value for R? 0.667. Right there. Value for N? 15. Sounds good to me. Okay. Give me R times the square root of N minus 2 divided by the square root of 1 minus R to the 2. A test statistic, 3.22. Hey, looks like B. 3.22. 97. 97. Is this a directional or non-directional hypothesis? Where?
Directional.
James. Yeah, directional. How do you know?
Because there's directions in hypotheses.
Yep, directions and hypothesis. These are also hypotheses. Hypotheses are everywhere, and they all have directions. So it's directional hypothesis. How many tails are there in a directional hypothesis, James?
1.
Yeah. 98, 81. 99 degrees of freedom. Degrees of freedom is n minus 2, n's 15. I'll give you this one, 13 degrees of freedom. 100. What is the critical value? We need alpha, which is 0.01. We need the number of tails, which is 1. We need degrees of freedom, which is 13. So a one-tail test, 0.01 significance level, 13 degrees of freedom, 2.650, otherwise known as just 2.65. Looks to me like a critical value is on the list. Yeah, 2.65. Last but not least, 101. I think I lost that page, honestly. Oh, here we go. Is the relationship real and positive, real and negative, or non-existent? Say it with me on the count of 3. 1, 2, 3. Oh, thank you. Real and positive. The answer 101 is real and positive. Anybody who wants to celebrate the fact that their homework is complete, I will tear up this paper into handmade confetti and shower you with it on the way out of here. But you made it. We did a lot of work this semester working on these homework problems. In the recent couple of weeks, we've done a lot more than we did earlier. But I think we did a fantastic job. We stuck with it. For that, I give you 12 more minutes of your Monday night back. Any questions?